think the starting point will be?
Would it be just let u equal, would it be, in this case, would you want to do the square root of 3ax plus bx3 or just 3ax plus bx3?
It's a very good question. So let's analyze. Very good question. Okay. So if I start with this, also, if you start with a substitution, it doesn't work, it's okay. Say, okay, this one didn't work, I'm going to try this one. It's not a problem. Okay, so I'm going to start with this. So remember, I have to have du, and du will be 3a plus 3bx squared dx. As I mentioned last time, or last week, and I didn't do it because I think it's really much easier, let's this time solve for dx. Fine. So du over 3a plus bx squared. That's fine. But remember, be careful because you cannot have x and u in the same integral. That's why I'm trying to avoid this situation. If you have x and u in the same integral, I can't give credit for it. So be careful with that, please. So dx, so I'm coming back here. So that's the integral from. Now, see, I cannot put them in because I will have x and u in the same integral. That's the problem. Okay, so when I put here,
can't you put that in because then the a plus b
right, but if I put it
squared
in here, then I have x and u in the same integral, and I can't do that.
Okay.
I have to do it on the side. So in other words, I'm going to the next page if you want, and take a plus b x squared divided by the square root of 3ax plus b x to the third, and then I replace dx by du, but not inside of an integral. You can do these calculations on the side, which I find them more cumbersome, but if this works for you, I'm fine. And then this is du divided by u, with a square root in this case. Then you go here and you say du over the square root of u, but you cannot do it inside of an integral. So you can do it on scratch paper, calculate whatever you want. You can throw this away. You don't even have to turn it in if you want. But I cannot have it inside the integral. So this becomes u to negative 1/2, u to negative 1/2 over negative 1/2, and plus 1, of course, and then plus a constant c. So this becomes the square root of u divided by 1/2 plus a constant c, or 2 the square root of u plus a constant c, and I go back to u. So this is 2 the square root of 3ax plus bx to the third plus a constant c. What I would have done, which is, this is perfect. If that works for you, please, that's absolutely fine. What I would have done, I would have multiplied by 3 and divided by 3. And then I see that all this is du, and I see that this is the square root of u. And I would have not needed to do all this. But again, if that method works for you, it works for me. So that's exactly what I have. So that 3a 3bx squared is this. Okay, and then du, and then the square root of u.
I gotta ask, why did you multiply the function by?
And there is a 3 here.
I was wondering, why did you multiply the function by du over the?
Say it again.
Why did you multiply, like the work you did on the side there?
Yes.
Like, could you pull it up? Not on the side, not the other paper. Yeah, I was wondering, why did you multiply the function by du over 3?
Okay. So the function, the original function was this and this. I'm replacing dx by this.
Understood.
Then we eliminated this. Don't forget the 3, which I did. There is a 3 in here. And then we put it back, which is exactly the same thing. I'm not saying that this method is not acceptable. It's perfect and acceptable. It's more work, in my opinion. Okay, so then the answer would be, so there is a 3 here. I forgot this 3. So, and the whole thing. And no problem, because you can go back and verify. Now, let's also look at the other option. There is no need to look at this other option because one of them worked. That's fine, but let's work on this. So here du will be 1 over 2 the square root of 3ax plus bx cubed times the inner function prime, which is 3a plus 3bx squared times dx. And this is nice too. So let me start from scratch on the next page. So we have the integral from a plus bx squared over the square root of 3ax plus bx to the third and dx. And we have du, which is the same thing with this, but with the 3 in front. That's all there is. Don't be afraid to make up a factor. You cannot add 10. That's not possible. You cannot subtract something, but a factor is always easy. We can multiply and divide by that number without any change. Any change. Okay then. So then with a 3 times this, times this, times the, divided by this and the dx is just du. So this is 1/3 the integral from du. So this will be 1/3 u plus a constant c. And now I have to go back 1/3, and we have u. U was the square root. And we have a 2 in the denominator. So 2/3, the square root of a3 is 3. 3ax plus bx to the third plus a constant c. We have to get the same answer. And you can say, okay, show me. Yep, that's no problem. So when I differentiate this, I have to get the original function. 2/3 times 1 over 2 the square root of 3ax plus bx to the third times the inner function prime, which is 3a plus 3bx squared, and the constant prime is 0. These two will go away. The 3 comes out and simplifies the 3 in front. And we get the original function back. So we know that this is correct. So this is the correct answer. And we did it in 2 ways. Not always, so for all functions you will be able to use 2 different ways. Both are fine. Is this, yes?
For the first way, why was the 3 in the denominator and not in the numerator?
But we solved, right? We solved. You asked me to solve for dx. I have du over all this. If you solve for dx, you have du at the top, and you have this in the denominator.
That's what I did wrong in my head.
Yeah, if you don't factor out the 3, then you will not be able to simplify these 2. So in order to simplify these 2, you have to pull out a 3.
Yeah.
So the du is du. This is the square root of u, but then the 3 has to be there. Is this better? Would you like to choose the next problem so I know what you think is requires more attention? Let's look at anything else.
What made us choose the square root of 3ax plus bx?
This one? Very
Yeah,
good,
what
very
made
good
us-
question. Very good question. So, number one, the first option is definitely this. Because I have the square root of a sum. The square root of a sum bothers me because I can never simplify the square root of a sum of two terms. I can simplify the square root of a product, but not the sum or difference. So that's my first thought, to consider this u. The second thought is the fact that it's in the denominator. The square root is in the denominator. And I know that when I differentiate this, I will get something with blah, blah, blah over the square root. So that's why the second indication, or the second thought. First thought is, I don't like this inside of the square root because I can't simplify it. The second thought is, oh, but if I denote, or I let u be the square root, I know that whenever I differentiate a square root, I get blah, blah, blah over 2 times that square root, which is here in the denominator. If the square root is a very good question. If the square root were in the numerator, I would have not tried that option. But because the square root is a denominator, and knowing that when I differentiate the square root of a function, I get blah, blah, blah over 2 the square root, and the square root is in the denominator, this could be a good option. It's a very good question. Thank you for that. Is this okay? Other questions on this?
We do another substitution because I'm still
As many as you want. This is what we're doing today, reviewing. So would you like me to choose or you want to choose?
you can.
You trust me to choose. Okay, then. I will choose. I don't think that this is a good color. No, this is not a good color. Okay, I'm choosing 31. It's the integral from e to r 2 plus 3e to r raised to 3/2 dr. Am I copying it correctly? E to r 2 plus 3, e to r 3/2. Okay, so what do you think?
I think u can be 2 plus 3 e to the r.
Of course, because du equals 3e to r. Of course, dr. So now, what are my pieces here? Nice. It's just a factor. It's easier if it's just a factor. If it's not just a factor, then solving for dr it will be a better option. But if it's just a factor, it's not going to be a big deal. So this is du. And all this is u to 3/2. Are we okay so far with this?
Yes.
Good. So that's awesome. So you understand 1, 2, 3 factors are here, which I used the du for. And all this is u to 3/2. So then 1/3 u to 3/2 plus 1, which is 5/2, over the same number plus a constant c. And then I flip, I get 2 over 15. And this is u, but I have to go back to u now, to power 5/2 plus a constant c, which is 2 plus 3 e to r. I only think that we did not get to, I mean, we had enough examples, I thought, but I don't think that this topic requires even more examples. So how do we feel after this one?
A bit better.
Awesome. Okay, let me choose the next. Or you want to choose the next?
I guess the ones I have more problem with than others are ones that are like a fraction.
Okay, very good. Here's a fraction. Let me know. You feel free to choose, please. Arctangent x squared divided by x squared plus 1 and dx. Any thoughts?
Let u equal arctan
Absolutely,
or arctan.
yes. But remember, du equals 1 over 1 plus x squared dx. It couldn't be easier. Du over x squared plus 1 or 1 plus x squared, it's intentional, right? They gave it to us intentional because we know this formula, but it's the same thing, right? So dx over this is du, and this is u squared, because that's what we used. And finally, I have arctangent to the third over 3 plus a constant c. Here, I didn't even need to do anything. So solving for the x will be more difficult in this situation because you cannot put the integral symbol. You have to use this calculation or put the calculation on the side. Simplify. You will have x and u in the same integral, and that will be a tragedy. So understanding that here it's all set for us. We don't even need to fabricate a 3 or a 2 or a 5. Everything was set for us. Dx over x squared plus 1. This is du. And this is u squared. Again, solving for dx is very, very legitimate, acceptable, perfect. But it will mess you up, potentially. For the simple ones, any questions on this problem?